Thank you, everyone. Super excited to be here today. It's been a minute since I've been at a conference in person. It's actually been 3 years. So it feels good. I forgot what the heart flutter is like when you're presenting live, right? We got a lot to cover, so I'm going to jump straight into it. OK, there are 3 themes that I want you to keep in mind as I go through this presentation, but also represent why we're here and why we're partnering with Anyscale. The first is accelerated computing meets orchestration efficiency through distributed computing. If you think of the value prop of accelerated computing, that's the ability for you to do more, right, for a fraction of the cost. The recurrent themes throughout this presentation, throughout this summit, are all about doing things faster at a fraction of the cost. So a value prop of doing more for less is fundamental to everything we're doing. The second piece is, right, a lot of this stuff is happening in the open source world. But I think it's super important that we give you guys a path to get into production, right, to get into production AI. I thought it was really interesting that when Ben Horowitz was asked what are going to be some of the pitfalls, right, for large language models, he started talking about role-based access control, right? So security and compliance and CVE patching, right, giving you a path to enterprise grade. And the final piece is about being cloud native, right? And yes, a lot's happening in the cloud. But I think cloud native is about meeting you where you guys are, right? So for sure, there's a lot of our stack in the cloud, but you might have a GPU in your local workstation, giving you a path to start locally and then scaling to the cloud is part of that value prop. OK, yes, we do GPUs. But NVIDIA is a full stack company, right? It's a full stack company. And I don't think people realize or appreciate the breadth of the software that we have to offer. We have 4 million developers that are enrolled in our developer program. There are more than 400 SDKs and pre-trained models that we make available through NGC, our container registry, right? 40,000 enterprises have deployed their applications in production on NVIDIA AI. So just a vast ecosystem of software that we provide. Again, I go back to saying, like, we are an accelerated computing company. The value comes from the software. In fact, the majority of the engineers working at NVIDIA today work on software. And the software that we create, right, is across the workflow, right? These are baseline libraries that we build domain-specific SDKs on top of. Rapids is great for ETL, right, prepping tabular data. Again, the value prop is always we can do things faster for a fraction of the cost. I was really happy to hear about Theano yesterday. I grew up in Montreal. Right? For as long as I remember, we've been contributing to open source frameworks. We upstream all of our optimizations. So people no longer do training without accelerators, right? So PyTorch and TensorFlow are 2 of the most popular open source frameworks. TensorRT is our optimizer and our model runtime, right? We'll be talking about TRT-LLM. And Trine is our inference server, right? And the ability for us to do inference at magnitudes greater on our accelerators versus GPU loans. So again, we provide optimizations across the end-to-end framework. And then we provide domain-specific SDKs that we build on top of these libraries. And that's what we're here to talk about today. We're here to talk about Nemo. Nemo is our end-to-end cloud-native framework for building, customizing, and deploying generative AI. It's comprised of a training container, comprised of an inference container, and it's got tooling for data prep or curation, and also guardrails, right, to make sure your model stays in check. I'm going to go into some of the specifics across some of these capabilities. So as the expression goes, garbage into an LLM, the LLM is going to spew some garbage out, right? And so the data curator is unique to Nemo. It allows you to curate high-quality data sets, right, to train your state-of-the-art foundation models. It removes deduplication, right, to ensure there isn't bias in your data set, right? Allows you to do blending and filtering. So I'm Lebanese. If you are to change a large language model, right, 70% of that's got to be English. But then the other 30% has got to be in Arabic, because when my wife and I fight, it's typically in Arabic, right? So you got to make sure you have the right blend, right? Other things it does is it can read HTML, JavaScript. We use a data curator. I think one of the main value props as well is we use a data curator to train one of our own models at NVIDIA. I think we started with 3.3 trillion tokens. After cleaning, deduplicating, filtering the data set, we ended up with 1.2 trillion tokens. What that meant actually reduced our training time by right? So higher quality data set, reduce our training time. Again, value of accelerated computing. A couple of things on the roadmap that we keep getting asked about is we will support mixed modals soon, so you can inject documents such as PDFs. And then data creation is also on the roadmap and something that we get a lot of asks from. I'm going real fast because there's a demo that I want to show at the end. I got jealous from the Adobe guys, so we want to make sure we show you our demo. Or not jealous, I should say, inspired, right? Inspired. OK, ways to customize. Did anybody see LangChain's, Harrison's event yesterday? I mean, I thought he did a masterful job at explaining how to provide context. So there's prompt engineering, right? That's few-shot learning or chain of thought reasoning, right? Like the way you prompt it, the way you customize it through the spoken language of English. Prompt learning or p-tuning is when you actually put an LSTM in front of the large language model, right? So you're not actually changing the parameters of the large language model itself. PEFT, or parameter efficient fine-tuning, is when you only alter a subset, or you fine-tune a subset of the parameters in the large language model, right? Again, with task or domain-specific data. And then obviously fine-tuning is RLHF or supervised fine-tuning. Again, here it's more data-intensive, more compute-intensive, right? And essentially you're changing all the parameters of the model. So the gist of the slide is, the further right you go, the more complex it gets in terms of training, but the more accurate it gets. But that comes at a cost of potential increased compute, data, and resources. TensorRT-LLM, right? Hopefully you guys caught this on stage yesterday. This is all about making inference compute as efficient as possible. We just released this or announced this, I want to say 10 days ago, a week ago, right? And already our engineers are working very hard with the Ray team's engineers, right, and the Anyscale engineers to integrate this in the next release of Ray Serve. It's an open source Python API for defining, optimizing, and executing models. It builds on top of our TRT compiler and faster transformer, consists of pre-processing, post-processing libraries. It's got optimized fusion kernels that includes flash attention, right? What else? I think I caught pretty much everything. Oh yeah, benchmarks. Why? So with the CNN Daily Mail data set for article summarization, all right, where we had a variable I/O length, compared to an A100, right, with GPT-J, which is a 6 billion parameter model, we saw 8x improvements in latency, right? On A100 versus H100 with TRT-LLM. From a TCO perspective, that was a reduction of 5.3x. And from just a power efficiency perspective, like we're talking about between 5 and 6, 5.5x, improvements. But everyone's talking about Llama 2 70B, right? So I think it's only fair that I share what kind of optimizations or performance gains we saw. It was 4.6x with Llama 2 70B from a performance perspective. TCO was about 3x improvement. Power efficiency about 3.2x improvements, right? Super important. LLMs are highly dynamic, which means that output length varies, right? Like chatbot Q&A is different to LLM generating long chunks of code, which is different to document summarization or document creation, right? And so what happens is versatility makes it difficult to batch all these requests and execute them at once. One of the main features and why a lot of these performance gains are seen is because of in-flight batching. And that's an optimization scheduling technique. What it essentially does is it evicts a sequence that are complete and begins executing the next sequence, right, while the new ones are coming in. Right? So it really drives that concurrency. And the last thing I want to talk about here is quantization. What quantization does is it allows you to go from reducing precision, so from FP16 to FP8, without compromising on accuracy, right? So it reduces the footprint of the model, allows you to fit it in smaller memory footprints. Talking about Triton, how am I doing on time? I'm OK on time. OK, so Triton is our inference server. We are in discussions with the Ray team in terms of how we're going to figure out what the right integration points are here, right? But one of the things we bring to the table is we support all the backends from all major frameworks. your favorite training frameworks to TensorRT-LLMs, obviously. We support different communication protocols, HTTP, gRPC, C++. It works on GPU and CPUs. Crazy, right? Crazy. Works on ARM, x86, Jetson, works on Windows. Supports different type of queries, right? Whether that's real-time, batch, or streaming. And one of the things that I think is super important or critical about Triton, and again, this is one of those things we're collaborating on, is the model analyzer. And what it does is it's a tool that finds optimal model configurations to maximize performance by looking at different constraints. So you specify like your latency, your throughput, your GPU memory, and what it does is it automatically sweeps through different configurations and gives you back, right, an optimal route based on those constraints, right? It's called the model optimizer. Okay, guardrails. What are guardrails? Guardrails are an open source toolkit to basically not enable jailbreak policies. So developers can use guardrails to program like filters or rails. It's almost like a dialog manager for LLMs, right? It uses fuzzy logic and large language models under the hood to understand the prompts and like generate the responses as well. And you can programmatically add topical, safety, and security rails. What's an example of each? Topical could be something like, hey, stick to the subject matter at hand. Don't talk about sports. Don't talk about financial disclosures. Don't talk about competitors, right? That's a nice thing to do. Safety can be about, don't spew any toxic content, right? Don't be harmful. You can actually teach the model not to be harmful. Like prevent hallucinations. Exclude personal information, right, in your responses. Could be another one from a safety perspective. And security is all about like restricting the app from making connections to just like verified or certified APIs, right? So you can actually dictate what it can speak to. What's awesome about the guardrails is they sit between the user interaction and your chatbot, and you can connect it via toolkits like LangChain, among others. Okay, so I know I went through a lot, but there's also a lot for us to cover. So we talked about the value prop of accelerated computing in the context of Nemo, different ways to customize it, different ways to ensure that the data that you're bringing into the model is curated, balanced, unbiased, right? All the way through inferencing to make sure your model stays, in check, right? Now let's pivot real quick and think about enterprise software, what it means to be enterprise software. As I told you guys earlier, we containerize a lot of our software. What people don't realize is there are 4,000, I know these numbers accurately because I had to count them for our CEO, 4,471 NVIDIA packages, open source packages, and third-party packages, creating 9,256 dependencies, right, across these base containers. It's a gigantic body of work that we have to maintain. But we do this on a monthly basis. I want to spend a bit of time on this slide. So what do we do every month? For TensorRT, for Triton, for PyTorch, we figure out what are the right set of 500 packages for a given container, figure out what the right knobs are to tune it so we can get the best peak performance on our GPUs. Before we make that container available on our container registry, right, we scan it, we address critical and high vulnerabilities. Anybody know what vulnerabilities are? Right? When you're dealing with open source software, right, attack surface for exploiting grows considerably, right? When you're absorbing a cloud service, your cloud provider is usually doing that patching for you, right? But if you're deploying containers, right, the vendor or as the enterprise or the user, you want to be patching those containers as well. So before we make any of our software available, we patch it for critical and high vulnerabilities. But we never go back and touch that container. Next month, we go through the exact same process. Right? We pick the right set of libraries, the top of tree, latest PyTorch release. We turn all the knobs, we squeeze the best performance out of it, and we publish it on NGC. Right? We scan it, we publish it on NGC. One important point to call out. Vulnerabilities are a point-in-time statement. That means because a container is free of vulnerabilities today, if you rescan that container 2 weeks from now, you're going to find new critical and high vulnerabilities. And our posture to date's been, don't worry, Mr. Customer. right? Next month, I'm going to publish a new container. New set of libraries, but it's going to be a new container. The day I publish it, it's not going to have any critical or high vulnerabilities. The problem with that is, right, by changing libraries, you introduce breaking changes into the container. Right? Changing the libraries can introduce breaking changes to the containers. And that might be OK if you're doing development, right? But would be problematic if you're doing inferencing. Right? And so what I've described is what we call our development branch. With NVIDIA AI Enterprise, which is basically taking our open source software, we're introducing production branches next month, right, and long-term supported branches. What that means is, for the production branches, for a duration of 9 months, 2 branches per year, we're going to do all that patching without changing the underlying libraries, right, without changing the versions of the underlying libraries. And so what that provides you is guarantees, SLAs, that NVIDIA will commit to fit critical and high vulnerabilities without changing APIs on you. And the bottom row is even more draconian than that. It's for long-term supported branches, where for a duration of 36 months, right, we undertake that patching and maintenance, right? So you know that for 3 years, a minimum of 3 years, you're going to have the same stack that you could deploy on. Now, some of you might be wondering, like, in what world would you do this? Plenty of domains, auto, medical imaging, right, telco, right, where you're doing a lot of deployments, in remote areas. And so I think the important piece here to call out is that these aren't mutually exclusive. We see enterprise and organizations using development branches for the latest features. I want to do sparsity XYZ, right, with the latest PyTorch container. But hey, for my production deployment, I want the Train Inference server or TensorRT-LLM server, right? I need it to be stable, right? And so again, just a gigantic task when you consider the amount of packages that are part of these different containers. Thanks to my good friends and colleagues over here, this is an Anyscale Platform value prop slide. And they could probably speak more to it than I can. But I just thought it was, given what the 3 value props I've been talking about, right? Like accelerated computing, TCO, make sure we're production grade, and meeting developers where they are, right? I didn't alter this slide. But that message is pretty consistent with what we're talking about, right? And so that's why I think this marriage, this relationship between Anyscale and NVIDIA, that's just beginning now, is going to grow and improve. Real quick, RAGs. And this is a pretty straightforward example, right? And again, kind of goes back to a lot of the use cases we're seeing are about using retrieval augmented generation. And so what that means is just making sure that your model's got context, right? Has access to your knowledge base, right? It's a pretty layman example here, but I was trained a couple months ago, so I got no idea what what was charged on your credit card. And so the demo that we're going to show is a RAG-based demo. We're going to show basically how we use LangChain, we use Ray, we use Anyscale to build a RAG-based copilot. And to be honest with you, right, as the infrastructure, full stack accelerated computing company, right, I'm acting like a trusted advisor here, right? I'm not telling you to go customize models, right? We're not asking you to go customize models. More often than not, a copilot with an enterprise's IT data, their HR data, their travel and expense data, right? That's a use case that every enterprise can benefit from. And frankly, that's what all the enterprises that we're engaged with are trying first and foremost, right? RAG-based approach. So a couple of software pieces that we're going to leverage as part of this workflow. Number one is Workbench. What Workbench does is essentially does a couple things. If you have a GPU, it enables anybody with a GPU on a local system to become a Gen AI creator. Through this concept called project, it sets up all the drivers, the stack on your given machine, makes it really easy for you to spin up a Jupyter notebook, pip install whatever you need. And as your compute needs grow, you can stick it back to the cloud and then deploy it on a cloud service provider of your choice. So it just makes it super easy. It's an early access. I think we're going to start admitting folks next month. I'll share the link towards the end of this to make it available. So why did I introduce Workbench? Well, this is the demo we're going to go through. Right? We're going to pick a Llama 2 model. We're going to use the TensorRT-LLM container that's embedded as part of the Nemo inference container that I spoke about. We're going to use Workbench. We're going to create a Ray-compatible environment locally, right? Then we're going to scale to the cloud as our compute needs grow. And so, without further ado, hopefully it's not going to muck up on me. Again, inspired by the Adobe demo.
NVIDIA and Anyscale are partnering to provide developers an easy way to build and deploy large language models faster. Ray, Anyscale's open-source platform, offers the flexibility, unification, and orchestration efficiencies developers need to easily distribute and parallelize their code, while NVIDIA delivers the performance and optimizations needed to run large language models, or LLMs, at scale. Since taking LLM-based code from open-source software to production is new for many developers, we'll show how easy it is to start from open source to build a custom Llama 2-based copilot and then deploy it into production with Anyscale and NVIDIA AI enterprise software. Copilots provide a conversation interface that uses an LLM, so anyone within an enterprise can create new content, generate ideas, and automate tasks. Here's the end-to-end workflow for developing a copilot. It starts with the developer working on a GPU-accelerated local workstation. The NVIDIA AI software needed to create the copilot is pulled from the NVIDIA NGC code repository and is built to be compatible with Anyscale's Ray. NVIDIA AI Workbench is used to launch Jupyter and pull the Llama 2 language model from Hugging Face. We ask the model a question about NVIDIA and Anyscale's partnership, but since the model hasn't been augmented, it provides a generic response with no mention of NVIDIA AI software. To fix this, we'll augment the Llama 2 model with a vector database and LangChain using a Retrieval augmented generation, also called a RAG, pipeline. Documents related to NVIDIA and Anyscale can be uploaded using local resources or scaled using the cloud. Since we have thousands of documents, we need more compute resources. It's easy to create embeddings and prepare for production deployment in the cloud since we already set up a Ray-compatible environment. By leveraging Anyscale's command line interface and NVIDIA AI Workbench, the whole project is uploaded to an Anyscale workspace. Before deploying the model, we need to optimize the Llama 2 model with NVIDIA TensorRT-LLM, which is now supported in RayServe. This provides massive latency improvements. Deploying the RAG-improved model across multiple nodes as an Anyscale service is achieved with one command. Next, we grab the endpoint information and easily integrate it into our enterprise application via Python or curl. Since the model is augmented with the latest information, it delivers a more accurate response to the question about NVIDIA and Anyscale's partnership. Together, NVIDIA and Anyscale are making sure that developers can quickly and efficiently create language-based generative AI applications, and NVIDIA AI software ensures compatibility, low latency, and high throughput inference. Sign up for a free NVIDIA AI Enterprise 90-day eval to get started today.
Yeah, so hopefully you guys found that exciting, right? Creating a Ray-compatible environment was as easy as like a pip install in a Docker file. Super easy. Then we spawned up a Jupyter notebook using Workbench, which set up all the infrastructure you needed for the GPU like locally. We then pulled a Llama 2 model. Then using the Anyscale CLI, it was super easy to farm back out to your platform, where, right, because we had a lot more documents to store, to create the embeddings and store them in a vector database, right? We used more compute there. Again, all was super easy. But I didn't do any of the work. It's the team that's sitting here up front. So you guys have any technical questions? Tanae, AC, Judy, put up your hands. Don't be shy now, right? Take the credit. They're actually looking like, no, we didn't do this, Adel. You want to take credit as well? OK, so kind of bringing all this together, right? And then we'll have some time for questions. When we talk about presented a lot, right? And I think the idea is you can start anywhere. You can start with open source and know that you have a path to production or enterprise-grade software. Starting with open source, right? We're an accelerated computing company that's a full-stack value prop. That means, right, you could do more for less, higher throughput for a fraction of the cost. I think when you talk about distributed computing and orchestration efficiency, that's the same KPIs. No, that's fundamentally the same KPIs. Second piece is, hey, how do we bring enterprise-grade software? And I think between the Anyscale platform and the NVIDIA AI enterprise production branches, right, you have that confidence, that security, that not only your software is going to be patched, you're going to meet compliance needs, security, et cetera, but you can actually call 1-800-NVIDIA, right, from a support perspective if needed. That is true, by the way, right? I forgot to mention that. With our enterprise offering, there are SLAs for response times directly into NVIDIA. And the final piece is, I think, right, Anyscale is a platform, AWS, Google Cloud, right? NVIDIA AI Enterprise is available on those CSP marketplaces. We've got VMIs. We're starting to integrate in their platforms as well. And so we can meet you as needed in the cloud. I think that is my final slide. Next steps is, yeah, you can screen that QR code. Gives you access to a 90-day eval. For 90 days, you get free access to NVIDIA AI Enterprise software. That's crazy talk. That's worth a lot, right? Yeah, go check it out. It'll also, I think, keep me honest, Judy, right? It also gives them the opportunity to say, hey, as your Anyscale NVIDIA integrations are in place, right? You can sign up, and we'll reach out as we make those libraries available. And with that, I think that concludes my session. That is correct. Any questions? Yes, sir. Oh, yeah, sure.
Thank you. So early on, you mentioned TensorRT-LLM for inference. You give some examples for acceleration multiple X. Are those also available for A100 or only for H100?
No, TRT-LLM works on both A100 and H100. In fact, what I was comparing was how much better it gets with H100 versus an A100. So when you talk about GPT-J, and I was saying 8x performance improvements, I was just showing you that TRT-LLM running on an H100 drives 8x improvement versus an A100. Okay. But it is supported on TRT. It is supported on A100s as well.
Okay. All right. But those numbers you showed us, like multiple X, for example, there is like, let me just put my notes here, 8x speed up on foundational language models. Those like 8x over A100.
Correct.
By H100.
Yeah, actually,
okay.
I think there's a blog that we published about this. Make sure that. Oh, never mind. Can't bring it up here. I do have a table to show for this. There is a blog that we publish, a developer blog, that goes into all the details that we have for those benchmarks. But yeah, we're not comparing against other accelerators. We're comparing versus older generation of our accelerators. But yeah, 8x was what we saw for GPT-J, for the CNN Daily Mail summarization data sets.
Thank you.
Yeah, no problem. Any other questions? Hi.
Hi. Could you elaborate a little more on the integration point, if it's okay to share without breaking disclosures, of faster transformer backend plus Ray, especially in the context of serving multiple LoRa fine-tuned models?
Yeah, what can I provide? So it's not faster transformer. We're doing a TRT-LLM integration. TRT-LLM builds on faster transformer, right? I mean, I don't know what additional detail I could share other than I think in the next release of Ray Serve 2.8, which happens 6 weeks from now, we should expect some of the first integrations coming to market.
Thank you.
No problem. All right. I think that's it. Thanks, guys. Thanks for having us here.